In this video, I want to talk about the rank theorem. We're going to let A be an m by n matrix, and in this case, there are two pieces to the rank theorem. The first piece says the dimension of the column space of A is equal to the dimension of the row space of A. And this is going to come pretty obviously because they both come from pivots. This comes from the pivot columns, and the number of pivot columns, the dimension of the row space comes from the number of non-zero rows. And these are going to correspond perfectly. If my row is not a non-zero row, then it has to contain a pivot. So therefore, the number of non-zero rows will be the same as the number of pivots, which is the same as the number of pivot columns. The second piece of this says that the rank of A plus the dimension of the null space of A is equal to n, the number of columns. The rank is just the dimension of the column space, so it's determined by the pivot columns. The dimension of the null space is determined by the free variables. And free variables are determined by non-pivot columns. And so when we think this through, we have the number of pivot columns plus the number of non-pivot columns has to equal all of the columns, since every column will either contain a pivot or not contain a pivot.